Hello guys, I'm Tosin Harold. I'm a data scientist and I just love everything numbers and data, crunching them. Sometimes they usually feel like food and sometimes they usually headaches. Okay, that's by the way. Today, I just want to run us through how to enhance our correlation metrics. It map plots with p-values in Python. And so, in case you don't know, correlation metrics plots are a valuable tool in data analysis as they help us to visualize the relationships between variables in a data set. Pretty much, it's just for us to identify patterns and dependencies among different features. And the idea behind this is it's crucial for data-driven decisions, but then correlation value alone doesn't always tell the whole story. Most times when you're trying to make inference, coefficients alone, having that can't, you interpreting it that way, it's not enough. So that's where p-value comes in. So the importance of p-value is for statistical significance. It indicates whether the observed correlations are statistically significant, which means a low p-value, typically less than 0.05, suggests a strong and meaningful relationship between variables, while a high p-value implies a weak or random correlation. And then we also have the importance in terms of the confidence in interpretation, testing hypotheses, and then identifying meaningful patterns, like I said earlier on. And so we just dive straight into it so that I don't waste your precious time, and I won't want this video to be so long. So first and foremost, we will start by loading our libraries that we're going to be using for this. And then I've pulled the data from Cargo. It's a solar energy data. And we're loading this. Let's just see what it looks like. So we're just using few columns there. I already looked at the data, and so I just picked few columns just for the sake of what we want to do. So with that, we can start writing our code snippet. But first, let me explain why we're using some of these libraries. The NumPy, of course, is for numerical computation, Pandas for data manipulation, Seaborn for visualization, inclusive with Matplotlib, similarly for visualization. TextWrap, I normally use TextWrap most of the time if there's a very long variable name and I need to kind of crunch that a bit so it doesn't look too messy. So I use TextWrap for that. I would show you how that's done here. And then the SciPy statistics function, then library, the Pearson R, Spearman R, and Kent et al. There are three different methods for correlation. You can check online to see the difference between them there. So the first thing we want to do is to let's first generate what the correlation metrics heat map looks like without the p-value. And so we start with generating these, and so we will put numeric only equal to false. So the reason why I'm doing this is I'm trying to get used to this because very soon it's going to be deprecated, and most of the time if you have texture data of observation of variables rather in your data sets, if it might generate error. So I'm just trying, because I've been getting a lot of warning about this for a while, especially if I have textual data, qualitative data in my set. So we have that. So the next thing we're going to do is let's mask. So the reason why I'm going to do this mask is because it's important that we don't have two sides of the diagonal when it comes to the correlation metrics, and a lot of people just usually leave it like that. I don't personally like it because it kind of clogs the whole space. I just want what I need, and so I tend to remove the upper part, and that's what we want to do here. So we have MP zeros, like we put in our correlation. So I'll fast forward these so that I do not bore you. Okay, there we go. There's something okay, this should not have I don't know why I always messed that up. So yep. So with these we can now put up our plot. So let me put it inside this line so that we don't have too much. and we set our fit size. Let's use 10.5. What next? Let's put a title. So in our title here, we'll just put correlation map without p-value. We can set the font size to 14. So the next thing here now is to generate. Let's generate our heat map. So we call that heat map equals to finesse.heatmap. Okay guys, so now we have everything here. So what I've pretty much just done is to plot our heat map. We set a notation here to true, and then we have a font size as 10, formatting it to have just 2 decimal places. Line width, of course, is just the line in between. And then the CMAP, we said that's the color of the mapping itself. We have it as red and blue. And then the mask that we already generated so that we could have a diagonal and leave out the other part of the diagonal. That's what we've set in here. And then of course we created the max here, so we used it in here. And then so let's see what our current so this is what a normal correlation map would look like without p-value. And so what we're trying to do now is to see, for instance, we're having a very strong correlation between temperature and radiation. So the question I would be asking in my head is this significant? Is this something that I can really say truly, like it's not just happening at random? So that's the essence of us including this p-value. And majorly, I think that's actually the strongest in terms of correlation. Most of them are kind of like weak and they're towards the negative part. So generally, this is just your correlation map. But then what we want to do right now is to be able to have our p-value so that at a glance, we can see what this is saying, or if the story is actually true. So the next thing we're going to do right now is we're first going to bring this back, this first part including okay, so let me start with this because we will need it in the same line of code. So I'll just pull all of this and bring it here, and then we can continue from there inside the same code. And so I will try to fast forward these two a little bit, and then from there I would explain exactly what we've done in the code at the end of the day. So let's go. Okay, so now we have everything we need right here. We're still going to run it so that we can test and see whether what we have done actually makes any sense or not. So let me quickly explain this code. So the essence here now is that we're creating it so that we can have p-values and have them actually formatted pretty well. And so the first thing we did was, apart from this first part that of course we've already done before and I've explained, so the first thing we did was just to initialize an empty array for our p-values. And so that where we have the p-values equals to mp.full blah blah blah, and by creating this with the same shape as the correlation matrix. And then we went ahead to iterate through the rows and columns of the correlation matrix using nested loop that we have around here. And then here we're also excluding the diagonal elements so that for each pair of variables indexed by I and j, it extracts the corresponding columns x and y from our data frame. So then we created a mask to identify valid data points by checking for the non-NaN values, and if there are any valid data points, the sum of the mask is greater than 0. It calculates the p-value using the Pearson R like we have here. So now I need to buttress this part because recall when I was saying that we could use either Pearson R or Kendall Tau or Spearman R. So in most cases, if you want to specify the method you want to use, you have to put it here as method equal to Kendall, for instance. So you can always overrun. So the same thing too with Spearman. So but by default, Panda's correlation actually uses Pearson. So that's the reason why we've put Pearson here. So if you're specifying any method different from Pearson R, so you will need to, I've already put a change to Kendall Tau or Spearman R. So the essence here is we're just trying to pull the p-values from our correlation. And then, so after completion of these, we for displaying only the lower triangle of the p-values data frame, and then we put this in a data frame, and then we iterated. So what we now did next was to try to get the max correlation coefficient and the minimum correlation coefficient. So idea here is we want to be able to have our notations for the p-values the way we would normally have it for the coefficients. Normally we want to be able to have it for the p-values to so it kind of like forms a contrast with the background color of that box, so that we don't have black on a very dark color. So that's the essence. So we had to get the max correlation and the minimum correlation, and then we subtract max correlation from 0.4 and then add 0.4 to minimum correlation. Anything outside the max core minus 0.4 and min core plus 0.4 is going to be black. And then we have our annotation, of course. Then we set the annotation so that at least it's kind of like leveled below the coefficient, and it's not kind of like fighting with the coefficient value pretty much. So the final part we did here was to, remember I told you, so let me just take this from here, similar here. So let's even try to run this first and be very sure that it's actually, yes. So this went perfectly well. Now we have our p-value under the correlation coefficient, and we can make more inference from this. So the idea now is for the temperature and radiation correlation of 0.73, we can see that the p-value equals to 0.00, far less than 0.05. So which is good, which makes sense that we can say, yeah, there's actually a relationship between temperature and radiation. But remember, correlation does not mean causation. So the fact that these two variables are they kind of have a relationship does not mean radiation causes temperature or temperature causes radiation. So with that side, so I think we have it beautifully well. We can see what's significant and what is not significant. We can see humidity with wind direction showing us p-value of 0.74, which means that's not even significant at all, even despite the fact that there is no correlation at all, or nothing going on, even though slightly negative, but nothing really going on. And so basically that's what it is. So now let me explain what the text trap will now do. So for instance, where we have this wind direction degrees, where it's kind of like already competing with space, with humidity and speed on the x-axis. So we kind of wrap the text so that some parts kind of like flows below that same text, and that is what we have here. And so now for these parts, what it means is that we're making sure that our x-axis and our y-axis actually have a wrap of 13. So that means after the count of 13 texts, it drops whatever follows immediately after that text. And so if we rerun this, we would realize that degrees is now below wind direction, which also applied because we did the same thing for y tick labels and we did the same thing for our x tick labels. And so basically this is what you can do to be able to get correlation map with p-value. Okay, I did not change this, and that does not make any sense. So this should be correlation value map with p-values. Okay, and so finally we can wrap all of this, because it's pretty much of a long code anyway, so we can wrap all of this into a function, which I've done here. So the only thing different which I had to automate here was the fact that so whatever data we have, we make a copy of that first, we still do the same correlation, and then I created a new function here to calculate and format the p-values. But now in this case, depending on whatever we specify as a method, which I've placed the default here as person. So whatever we specify, if we specify Kendall or Spearman, it automatically picks the right one, and then it will pick the p-value for us. And then it would also apply the same thing into the correlation. So that means whatever correlation we're doing here at the end of the day for the method is still going to apply for the p-values that would be created. So that apparently just automates all that part for us, and we just only have to call the function. And then finally we can now just call this, and then we have the same for that function. So we're only specifying the data frame, the method, the fixed size, and then the title, of course. And so that gives us the same thing as before. So that way we can just have only a single line of code for any of our project, and we can use this function across multiple projects, and that makes our work kind of like neater and a lot better without having to write very long line of code. So you can always replicate this for your own project, and I hope that this really helped you pretty much. And so I think with this, even if you use this for your research paper, for instance, or you're trying to tell your boss what's going on, and then you really want to explain to them that this is significant and this is something we should really look at in terms of the relationship between this and this. So basically that's just the idea. So at a glance you're able to speak to it, and anybody who is looking at it can also understand what they're looking at and be able to make meaning out of the story you're trying to tell with your correlation map. And so that's it. So please, if you like this content, please, like, even if you really don't like it, still like it. I'm just your own boy, just trying to see what I can do at least to push some things out. It's also for my own learning sake. So most times when I try to do some of these things, it's just to improve my own learning and also dish out some of the things I've learned, or I'm learning, or I'm coming across, as the case may be. So if you think you've been able to find this pretty helpful, kindly like and subscribe. I'll be very grateful, and see you in the next video. Thank you.